let us discuss about the Pascal's law. Pascal's law states that if the effect of the gravity is neglected, if we have got a fluid in equilibrium, that is, if we have got a fluid at rest, the pressure at every point of the liquid is the same, provided the effect of the gravity is neglected. Let us take an example. We have got a beaker with a fluid. That fluid is at rest. Let us take an imaginary cylinder AB. We know that when a body is immersed in a fluid, the normal force or the thrust exerts on it. As this imaginary cylinder is at rest, the sum total of the total thrusts or normal forces is equal to 0. Let us take this base and this top of the cylinder. We have shown that here the force F is on this cylinder of face A, and here the equal and opposite force F is on this top of the cylinder B. Why this force? Because the forces should cancel each other, because this fluid is at rest. So we can say that the pressure here PA is equal to what is force F and divided by A, where A, small a, is the area of this top and area of this base. Now the pressure at the point A is equal to F divided by A. The pressure at the point B, same force F exerts on this base, and the area is small a. So we can see that this is F by A, this is F by A. So PA is equal to PB. This is the Pascal's law, which states that when we have got a fluid at rest or a fluid in equilibrium, provided the effect of the gravity is neglected, the pressure at every point in the fluid or the liquid is the same. The Pascal's law gets us to an important conclusion that if there is a change in pressure at any point in the liquid or any point in the fluid, it is equally transmitted to the walls of the container, or it is equally transmitted in all the directions in the fluid. Let us take an example how. We have taken a sphere with 4 pistons. The piston area of first piston is A, another is A by 2, another is 2A, and another is 3A. We push the first piston by a force of F. So pressure here P1 is equal to F divided by A. The Pascal's law states this pressure difference, which is created by the pushing of the piston in downward direction, is F divided by A. So this F divided by, or this pressure difference, is equally transmitted in all the directions. When this piston is pushed in backward direction, these 3 pistons are pushed in forward direction. So we have got to push this piston, and this piston, so that they remain in the equilibrium position. Now we will see that what is the force required here. The force required at this piston, as the pressure difference is equally transmitted in all directions of the liquid or all walls of the container. So here the force F2 should be equal to P1 into A divided by 2. That is F divided by A into A divided by 2, that is F divided by 2, which is the same force with which we have to push the piston in this direction. Here we have to push it to F. We will see if the calculations are the right. In case number 3, F3 will be equal to P1 into 2A, that is equal to F divided by A into 2A. A and A cancels out, so that force is equal to 2F. So to keep the piston in place, we have to push this piston in the inward direction by a force of 2F. Let us take the last calculation. Now here we know that the force by which we have to push this piston will be equal to F4, that will be equal to P1 into 3A. That is F4 is equal to F divided by A into 3A. A and A cancels out, that is equal to 3F. So Pascal's law states as that when there is pressure difference in a fluid that is in equilibrium or state of rest, the pressure difference is equally transmitted in all the directions. We calculated here when there is a pressure difference created by pushing the piston in the downward direction by a force F, these pistons get pushed outwards by a force of F by 2, 2F and 3F. So we have to push those with the same force to keep this fluid at equilibrium. When we calculated by the Pascal's law, the forces were exactly equal to F by 2, 2F and 3F, by which we had to push these pistons in the inward direction, which completes that the Pascal's law is valid in all situations, provided the effect of the gravity is neglected. Thank you.